Hi everyone, welcome to today's video where we'll be going over a full walkthrough of the Edexcel A-Level Paper 2 Pure paper. Let's go on with it. First question. Okay, so we've been given a function f of x, we're asked to find the second derivative. Okay, cool. So it looks like just a standard polynomial differentiation that we have. Nothing too complicated. Bring down the power and take away 1 from the power. So part A, f dash x, we're looking at 3x squared plus 4x minus 8. Now f dash dash, or prime prime, that'll be 6x plus 4. Nice. Part B talks about solving it equal to 0. Pretty straightforward. We make the derivative equal to 0, I guess 6x plus 4. So therefore x must be equal to minus 2 over 3. Part 2 is asking to find the range of value for which the f of x is concave. Now for a concave shape, we're looking for the shape that we're looking for. It looks like a sort of a sad quadratic, if you will, type of shape. And for that to be true, our second derivative must be less than 0. So f dash dash x must be less than 0. Which we know what it is, right? We know what the second derivative is, which is going to be 6x plus 4 less than 0. So x must be less than 2 over 3. Nice, let's move on. Next question. Okay, so we've been given some sort of sequences. We've been given the function for it. Asked to find u2. Here we'll just sub in u1 into the equation and it will just give us the value of u2 and hopefully that'll be 40. So let's see. So we know u1 is 35, so u2 is going to be equal to 35 plus 7 times cos of, so here n would be what we substitute in, which is the first term, right? So n must be equal to 1, so we get pi over 2 minus 5 times minus 1. So if we quickly sketch the cos graph, we can clearly see that at 90 degrees the value is 0. So we can say that this thing is going to go to 0. So that leaves us with 35 plus 5, because minus minus, and that would give us 40, and exactly what they asked for. So I'm going to say that's QAD. Let's move on. Next is asking you to find the value of u3 and u4. We'll just substitute u2 into the equation to get u3 and vice versa. So u3 is going to be equal to 40 plus 7 cos of, now n would be equal to 2. That's the sequence we're substituting. So that would be 2 divided by 2 will cancel out. So I'm just going to write down pi minus 5 times minus 1 squared. So that gives me 40. Now at 180 we can see that it's minus 1, the value. So that's key important information. So that becomes minus 7 and that gives me minus 5. So 28. Then u4 would be equal to 28 plus 7 times cos of, now we have 3 pi over 2 now, minus 5 times minus 1 cubed. So 270, again we're looking at a value of 0 at 270. So this thing goes to 0. So we end up with 28 plus 5, and that would give us 33. Nice. The next question is talking about the sequence being periodic with order of 4. Write down the value of 5. So if it's talking about a periodic sequence, i.e. it repeats itself after a certain period, in this case that's 4, and luckily for us we know what the first 4 terms are in the sequence. So the 5th term would be effectively your first term, because what you'll have is, this is my first one, which is 35, which we were given, then we got 40, then we go 28, then 33. As you can see, that's the 4 terms, so therefore that's the period of this sequence. So the next one we expect it to be 35. So therefore u5 equals 35. All right, next one is asking us to find the summation from 1 to 25. So 1 to 25 terms, the first 25 terms of the sequence. So here the idea is that how many periods are we going to have? So 25, that's 24 plus 1, or 6 times 4. So we'll have in total 6 periods, because every 4 terms our sequence repeats itself. So we'll have 6 periods. So the idea here would be that if we find what the summation of the sum of the period one period is, then I can times it by 6 to get 6 periods. So that would be 35 plus 40 plus 28 plus 33. And if I just punch it into my calculator, which is going to be 35 plus 40 plus 28 plus 33. So that's 136 per one period. So that'll be 6 periods in total. That gives me shift times answer 816. And remember, we're looking for the first 25. So this is up to the first 24 terms. So if we want to find the next, well, we know what the next number in the sequence is, which is going to be 35. So to find the entire summation, we just add 25 on. So we can say therefore summation of R1 to 25 of UR is going to be 816 plus 35, and that will be 1 in hand. That's 25, 851. I'm just going to double check I didn't fumble that one. Nice. Cool, I can do basic arithmetic. Right, next question. Logs and show some equation. In this kind of context, is usually what they're trying to point you towards is can you simplify these logs, and perhaps by simplifying you're going to be able to build an equation. So in this case, the idea would be to bring all of the logs on one side, and we can use and exploit the log rules to therefore find the equation that they've stated. So that's exactly what I'll do. So I'll bring all the logs on one side. So log of base 2 x plus 3 plus log of base 2 x plus 10 minus 2 times. So again, rather than writing 2 times log, what I'm going to do is I'm going to use the power rule ahead of time, because I know where this is going, right? So I'm going to say log of base 2 x squared, and that's equal to 2. And finally, now I can take log rules. So the ones we need here is the multiplication and the division one, because we're adding and we're taking away. So log of base 2 as a whole would be x plus 3 x plus 10 divided by x squared equals 2. Now we can get rid of the log, but we'll just need to raise it to the power of the base. So we get x plus 3 x plus 10 over x squared equals 2 squared. Then we can times both sides by x squared now, and also simplify the numerator while we're at it. So that's x squared plus 13x plus 30 equals 4x squared. And let's just bring everything to one side, and that should give us the equation we're looking for, minus 13x minus 30, and that's precisely what we're looking for. QED. Next, it's asking us to find the roots of the equation. Okay, nice and easy. We just go to our calculator. Sorry, trying to bring up the calculator. Sorry about that. So we're going into menu, equation, polynomial, second degree, 13 minus 3 minus 13 and minus 30. Oh. Okay, so our first solution, x1 is equal to 6, or x2 is going to be minus 5 over 3. Okay, cool. Next question says, hence state which one of the the roots of the log cannot be a solution. Well, here, if it's not obvious already, we can't have a negative log. That would give you an imaginary answer. So in that case, clearly, since we have one of the logs, which is just log of the number or the root itself, we have to make sure that it has to be positive. So we can say x2 or x equals minus 5 over 2 is not a solution since x is less than 0. Nice. Coffee is poured into a cup. Okay, been given the equation. Told initially, so initially means time equals 0. The temperature was 85. Which one's the temperature? H. That's an interesting letter to use for temperature. Okay, cool. So let's just, idea is, since we know initially, i.e. at time t equals 0, what the temperature is, we can just sub in those pair of values and we can find what A is. So we say that at t equals 0, H is equal to 85. So 85 is equal to a times e to the 0 plus 30. E to the 0 goes to 1, so we end up with 55 is equal to a. Part B. Initially, so time t equals 0, the coffee was cooling at a rate. So rate right away should give a hint to you that this is a differentiation question, or you have to find some kind of derivative, because every time we talk about derivatives, it's to do with time or is to do with rate. And in this case, cooling is also a very interesting word to use, because if something is cooling, you expect the rate to go down, so it will be a negative rate per minute. We need to find what the value of b is. Okay, cool. So we find dh dt. So we're differentiating an exponential, and when we differentiate exponential, we bring down the coefficient of the variable. In this case, that's t. So we bring down the b. So 55 times by minus b, e to the power of minus bt, plus 30. Now we know that is initially the rate is that minus 7.5, so we can sub in those coordinates. So we can say at t equals 0, dh dt is equal to minus 7.5. So minus 7.5 equals to minus 55b. Sorry, there shouldn't be any 30 there because it's a constant and we differentiate it. That's my bad, oversight. And then therefore b would simply just be, come back to the menu, it would be 7.5 divided by 55 is equal to, as a rate of 0.136. So the complete equation therefore h is going to be equal to 55 e to the power of minus 0.136 t plus 30. Yep, that's it, spot on. Nice, let's keep going. Okay, so we've been given some function f passes through point p is the turning point, and we're given the derivative. So in this case, since we know what the derivative is and we know that p is at a stationary point, what we can do to find k is we make the derivative equal to 0 because it's a stationary point, and since we also know what the value of the x coordinate of p is, we can sub that in and we should be able to figure out what the value of k is. In this case they want you to show that it's 12, so you can say that dy dx is equal to 0 at turning point. So 0 equals 2 times 3 cubed minus 9 times 3 squared plus 5 times 3 plus k. Then we get 2 times 27, so that's 54. 9 times 9, that's 81, plus 15 plus k, and I'm just going to say that's going to be equal to 12. I'm not going to bother with it. Oh, it's a short question, so QED. Let's not forget that. Hence, find the coordinates of the point where c crosses the y-axis. So if they're asking you to find what the y-axis value is, and we were given the derivative, correct? That's a hint that they're asking you to integrate and find what the function is. Another hint in this question that this is an integration question is because they've given you the point. Since they've given you the point, that means if you're going to have a constant of integration, because this is going to be an indefinite integral, and therefore you can sub in those points that you were given in the question to be able to find what the constant is. So those are the two big hints, right? So y is going to be equal to integral of 2x cubed minus 9x squared plus 5x plus 12 dx. So that gives me a half of x to the 4 minus 3x cubed plus 5 over 2x plus 12x plus c. So now what we have to do is at x equals 3, I believe y is 10. Minus 10. Good thing I checked. Minus 10. So I get is minus 10 is equal to, I'm just going to put all of this in my calculator and hopefully that works out. So I've got is 0.5 times x, which is now equal to 3 to the power of 4 minus brackets 3 times 3 cubed plus 2.5 times 3. Wait, should be square there. There you go. Sloppy mistakes. Squared plus 12 times 3. 18. Okay, nice coordinate. 18 plus c, so therefore c equals minus 28. And that is the y coordinate. That is indeed the y coordinate of the y-intercept. Why do I know this? Because it's usually the constant term that is your y-intercept. If you don't believe me, well, you can double check by saying that at the y-intercept x equals 0. So if you were to sub in x equals 0 into all of these x's, you can see that everything's going to go to 0 and your y will equal c, and c is your y-intercept. Okay, therefore y-intercept equals to minus 28. Right, next one. So we have relative to a fixed origin, we have 4 vectors. We need to show that AD is parallel to BC. So with vectors questions, if they're asking for parallel, the plan is that you find the individual vectors that they're talking about, and hopefully, if you've done the arithmetic right, one of them will be a multiple of the other, and therefore that tells you that they are indeed parallel because they're going in the same direction, albeit they have a factor that one is enlarged by the other. Okay, so A to D is going to be equal to, and when you're finding the direction vector, by the way, the first letter or the vector associated with the first letter is the one you make negative, if you want to think about it like how I do. And I'm going to use column vector because I like column vectors. Plus 22, 24, that gives me 10 and 24. Then AD and then BC, minus 0, 16. 50, 136, so that gives me 50 plus, what's that, 120. And clearly I hope you can see that this is effectively just 5 times AD, right? So I can say therefore BC equals 5 times AD, hence, or thus parallel. Nope, parallel and QED. Cool. Next question. So, okay, ABCD forms a quadrilateral. You have to run along 10 meters. Runner takes 5 minutes for 2 complete laps. Find the average speed in kilometers per hour. Okay, interesting. So in this case, what they're really asking you is, can you find the lengths of all of the vectors that we have? We add them up, and that will be our total distance. That'll be total distance for 1 lap. The runner does 2 laps, so times that by 2. We'll have the entire length that the runner runs. We have the time it takes the runner to run, albeit it's in minutes. Yeah, it's in minutes. We want in hours. We can easily convert that. And finally, we'll just use speed is equal to distance over time formula to find it all. Okay, so let's crack on with it. I think in this case, a little sketch could go a long way. Doesn't need to be any accurate at all. And they don't specify what kind of quadrilateral it is, and since it's just going to be an indication of the sketch, what I'll do is I'll just assume it's some sort of like rectangle. I think in reality it'll be more like a trapezium. So that's my point A, that's my point B, let's say this is D, and let's say this is C. Yeah, in reality it's definitely like a trapezium because AD is a lot smaller. And you know what, I'll actually try to stick to a scale of some sort. So let's say this is D. Okay, roughly that. Should be a bit more uniform, but you know, who cares. So in this case, we know the vectors AD and BC, so we know effectively how much is the length, although we have to figure out its magnitude. But we almost know the information, at least half of it. And then we need to find out the vectors a to b and c to d. And then if you find the magnitude of all of those, add them up, that will be the total distance that we've covered. So a to b, let's quickly find it. So a to b would be minus a and b. So minus 12 plus 16. Then we have c to d minus, minus 50 and 136 plus 22 and 24. 22 and 24. So that gives me what? So that gives me, so it's minus 50. I could definitely do this mentally, but I'm a bit lazy and I don't want to get it wrong. So 28, and then we have minus 136 plus 24 minus 112. So now let's find all of the magnitudes. So a to b, I think, is the nicest one. So we're looking for the square root of 12 squared plus 16 squared, 20. Nice. Then we have a to b, then we have b to c. And what was b to c for us? 50 and 120. Okay. Then we do 50 squared plus 120 squared. Plus 120 squared. Give us 130. Oh, these are nice numbers. Then we have c to d. C to d, that would be square root of 28. I don't think this is going to be a nice number though. So 28 squared plus 112 squared. Yep. 28 and root 17. And then finally we'll come back to d to a or a to d. I think it doesn't matter for when it comes to the magnitude. A to d was 10 and 24. This should be a nice number as well. 10 squared plus 24 squared. 24 squared. Yeah, 26. Okay, cool. So that is the distance for one lap. Let's add them up. So total distance, this is going to be 2 times basically all of these added up. So 176 plus 28 through 17. So that's my total distance. And my total time was 5 minutes. This is in meters, right? Okay, it's in meters. So I need to convert it into kilometers. So actually, before I find the time, what I'll say is this is divided by 1,000. So I can convert from meters to kilometers. And I'll put all of this in my calculator to find the answer. And then total time is going to be, it was 5 minutes. So 5 minutes over 60 to give us 1/12 of an hour. So therefore, the speed is what we're looking for, right? Okay, average speed. So speed is going to be the distance. So let's actually find this distance. So 2 times 176 plus 28 square root of 17. Let's just divide that by 1,000 to give us 0.5828 ... Then divide this by, well, actually technically just times it by 12 and we'll get our answer. So 1/12, and that will be 6 point, how many decimal places? Haven't been told. So 3 significant figures, 6.99 kilometers per hour to 3SF. Right, let's keep going. Next question. Okay, so we've been given some function. It has a mix of x and y. I'll be asked to find the derivative. So this is an implicit differentiation question. The way you figure it out, that it is implicit differentiation because you have both x and y being multiplied, and you're being asked to actually differentiate that. So when it comes to implicit differentiation, what you're doing is you do the normal differentiation using product rule, Okay, so you differentiate y as you would with the x, but the key thing here is that once you've differentiated the y, you have to stick in a dy dx. Okay, so you'll see what I mean. So if you have 2xy, I can treat this as product rule, uv dash plus vu dash. Sorry, my pen is a bit buggy today, I don't know why, but okay, cool. So 3x squared plus 2y plus 2x. Now I want to differentiate y normally, so here I differentiated x. Now I want to differentiate y because it's just y, it'll just give me 1. So I have to just stick in the dx dy dx plus 6y dy dx again equals 47. Oh, there's no 47, sorry, it would just be 0 because it's a constant and we differentiated it. And ultimately now our plan is, can we just make dy dx the subject, and that will be it. So I'll move everything that is not important, so i.e. that thing. So 2x dy dx, so 2x dy dx plus 6y dy dx equals minus brackets 3x squared plus 2y. You can expand it, I'm just going to keep it like that. And then dy dx is going to be equal to minus 3x squared plus 2y all over 2x plus 6y. Done. Okay, point P lies on the curve. We need to find the equation of the normal at point P. Okay, so here the idea is that since we know what dy dx is, which is your gradient function, if we were to sub in the point P into our gradient function, i.e. our first derivative, we should be able to figure out what the gradient of the tangent is. And since we're finding the normal, we know that the tangent and the normal, so if I have a curve, this is my tangent and this is my normal, and they meet at 90 degrees, so they're perpendicular to each other. So that is my tangent and this is my normal. So if I sub in my coordinate P into my derivative expression that I have, and then find the reciprocal, negative reciprocal of that value, I should be left with, which is the normal gradient. So dy dx at P is going to be, what's the point? Minus 2 and 5. Okay, so minus 2 squared plus 2 times 5 over 2 times minus 2 plus 6 times 5. I think this would take me forever to type into my calculator, so I'll try to do this without a calculator. So we have 4 times 3, that's 12, plus 10 over 4, sorry, minus 4, and that would be 26. So we have minus 22 over 26. We can simplify this further, so that would be 11 over 13 minus. And that's the gradient m of the tangent. And we know that m of normal is going to be equal to 13 over 11 because m tangent times m normal must equal minus 1. Cool. So now that we know what the gradient is, and we know the coordinate P which the line goes to, we can just use straight line equations from this point onwards. So we can say y equals 13 over 11x plus c. So then at minus 2 at P, which is x equals minus 2, we get is y is equal to 5. Sorry, yeah. So I get 5 equals minus 26 over 11 plus c. So c must be equal to 5 plus 26 over 11. This I'll just put into my calculator, I'll be honest. 81 over 11. So that's 81 over 11. Therefore, y equals 13 over 11x plus 81 over 11. Looks like they want it this format, so we'll need to bring everything onto one side, so that we're looking for minus 13x plus 11y minus 81 equals 0. So we times everything. Oh, where did that go? Yeah, so we're looking for, what we do is we multiply everything by 11 and then bring everything to the other side. Okay, nice. Okay, so we've been given an expression, trig expression. They want it in terms of our cos theta. Okay, cool. So here, what we'll do is we'll quickly hop on to the formula booklet, because you'll be given what the expression, the addition formula is for cos. There you go. So let's write that down. So cos of theta minus alpha would be cos of theta, cos of alpha, plus sine of theta, sine of alpha. Alright, cool. So now what we'll do is we will expand this, and the technique I'm going to use here is comparing coefficients, or the inspection method. There's many other ways. I feel the inspection method is very to the point when it comes to these questions. So A. Okay, so what do we have? So we have 2 cos theta plus 8 sine theta is equal to cos theta cos alpha plus sine theta sine alpha, and all of this is multiplied by some r. Honestly, we don't need to find what r is at the moment, because you'll see by the method I'm using, I'll cancel out r's anyway because I'm going to divide by it. So if I compare what's the cos values on the both sides, so cos theta, I can see the value on this side is 2, and the value on this side would be r cos alpha. Then sine theta, you can see is going to be equal to 8 equals r sine alpha. And the idea here is that I'm going to divide, I'm going to call this equation 1, I'll call this 2. I'm going to divide 2 by 1 so that I end up with 10. So 2 divided by 1, that gives me r sine alpha over r cos alpha. 8 over 2, r cancels. So that's what I was saying, it's not very important to find r at that point. And we'll have 10 alpha is equal to 4. So at this point, we'll switch over to the calculator. And are we looking for radians? We're looking for radians. So menu setup, angle, radian. And we do shift inverse of 4. 1.32, and that should be below 1.5, which is pi over 2. So therefore, alpha is equal to 1.326. 3 dp. And finally, let's find r. R is simply the coefficients of sine and cos. You do Pythagoras' theorem on it. So 2 squared plus 8 squared, that is 4 plus 64, so that's root 68. And I assume you also need to give exact value of r. Okay, fine. I feel like, is there a third in there? I feel like there might be. Yeah, there is. 2 times, okay, so 2 root 17. So therefore, what we're looking for is 2 root 17 cos of theta plus 1.3, sorry, minus 1.326. And that's my answer. Next question says, here's the first 3 terms of a sequence, cos plus sine plus 2 sine. Looks like they add sine every time. Given that S9 represents the sum of the first 9 terms, find the exact value of S9. Interesting question. So let's think about this. We're looking for an arithmetic sequence. So at this point, I want to switch over to the formula booklet, because you should be given what the formula is for summation. There you go, arithmetic series, that's the formula, and I'm going to use this one. So in that equation, the plan that I have is, if I use the summation, right, that I know, the summation formula, right, I use that and I get an expression for the sum for the first 9 terms. And I have a very good feeling that it will be something to do with the first part of the question. And if it is, what we can do is we can say that the max value that cos can take is 1, and somehow from there we'll be able to figure out what the max value is. Okay, so let's just focus on that. So we can see our difference every time would be sine x. our first term is equal to cos x. Therefore, S9 is going to be equal to a half of n, which is 9, times 2 times cos x plus n minus 1, which is going to give me 8 of sine x. And as I thought it was, when I say this 9, oh, that looks like an ugly 9. 9 over 2. And you can see that 2 cos x plus 8 sin x looks awfully close to what was our first part of the question, which was 2 cos and 8 sin. So we can actually use this compact form that we found, the wave function, whatever you like to call it. So that's 9 over 2 times by 2 root 17 times cos of theta minus 1.326. And like we said, the maximum value that cos can take is indeed 1, because of, well, it's a bounded function between 1 and minus 1. So we can say that the max value that you can take is 1, so therefore 2 cancels to give me 9 root 17, and that's my max value that S9 can take. I think that was part 1. 2. Deduce the smallest possible value of x at which the max value occurs. So the max value occurs when cos of theta is equal to 1. So if I do cos inverse of 1, that should be just equal to 0. And theta has to equal 1.326. Okay, makes sense? Lovely. Right. Parametric equations, we've been given x and we've been given y. We need to find the Cartesian equation. So interesting. So with parametric equations, what the usual ball game is that you try to find either x or y and make one of them the subject. Let me reword that. You find your variable that links your x or y, and you find that, and then you can substitute into the x or y expression. I think I don't know if I'm making sense or not. So for example, in this case, if you can make t the subject, right, and then you substitute it into the x equation per se, and then you can find something that is in terms of x, y in terms of x. But the issue here is I have a natural log, and if I'm trying to make t the subject, I'm gonna have some kind of like exponential floating about the place. So that's not gonna look good. I'm looking at x, right, and I see that t squared plus 6t. That interests me heavily, because if I do complete the square there, I can actually get something that would look like t plus 3. And where else is t plus 3? It's in the y expression. So actually, I'm going to do complete the square on x, find an expression for t plus 3, and I can grab the whole thing and just shove it into y, and I should get what the expression I'm looking for. So for part A, x equals t plus 3 whole squared minus 3 squared minus 16, is it? Yeah, minus 16. So t plus 3 whole squared minus 25 is equal to x. So x plus 25 is equal to t plus 3, and I'll say this is square rooted, so that's t plus 3. So now what I can do is I can say therefore y is equal to 6 ln of square root of x plus 25. And now we need to find something that is y equals x plus b. So clearly the square root can't stay, it has to go. Luckily for us, it's a log, so we can exploit the log rules, and I can say x plus 25 to the power of a half, and I can bring down that power to give me 3 ln of x plus 25, and that is equal to y. Nice. Okay, so we have the curve that cuts the y-axis at point P. P can be written in this format. Cool. So what this is asking us is, since we know what the equation of y is, for us to find the tangent, again, we find the first derivative, which would give us the gradient function, and it tells us that it cuts the y-axis, so x is equal to 0. We can sub that point in and find the gradient at x equals 0. Once we got that, we can also find the y coordinate of the normal function when x is equal to 0, and we'll have a pair of coordinate x and y, substitute into the y equals mx plus c equation, and therefore find our equation of the tangent. So hopefully that makes sense. What I'll do is, before I get started, I'll just do a bit of housekeeping. So I'll say x equals 0, y is going to be equal to 3 of ln 25. So that's just me finding the coordinate that I'm looking for. So I can later substitute this into my y equals mx plus c equation. Now we'll find the derivative dy dx. And since we have a natural log, it's simply 1 over that. So that's 3 over x plus 25. And let's find the gradient of the tangent, which would be at x equals 0. Which is 3 over 25. So this is my gradient of the tangent. So now we actually have everything we need, which is y equals 3 over 25, x plus c. And we can now substitute the point x equals 0, y equals, what was it, 3 ln 25, ln 25. And that gives us 3 ln 25 is equal to 3 over 25. Well, that goes to 0, so I'm not even going to bother writing it. So that's equal to c. And I think what I'm gonna do here is, I saw from the corner of my eye that it's a ln of 5, and if it's a ln of 5 and we have 25 here, ideally what we're looking to do is use the log rules again, the power rule again, so we can make 25 into 5. So we say 3 times ln of 5 squared, and we can bring that power down to give us 9 times ln of 5 equals c. So next, therefore I get y equals 3 over 25x plus 9 ln 5. And what do they want? What format? Okay, so they want it in terms of ax and by, so they want all the x's and the y's on one side. So if I times everything by 25 and bring over the x, I get minus 3x plus 25y. And what's 9 times 25? I have a feeling it's 125 if I'm not wrong. 9 times 25, 225, my bad. So 225 ln of 5. Okay, cool. So that's the answer for that one. Right, let's carry on. So now we have question 9, and we have a set of parametric equations. Okay, they're asking us to find the Cartesian equation. So the usual procedure with parametric equations and going to Cartesian is that we try to find an expression in terms of the third variable. So in this instance, that will be t. You make t the subject, then we sub it into the other equation and get x in terms of y, or vice versa. It doesn't matter which one. But because we have a natural log floating about in this one, I think that's going to make things look, one, look very ugly, and second, very complicated. So I'm thinking instead, I just looked at x. I can see that t squared plus 6t actually interests me quite a bit, because I'm thinking if I do complete a square on t squared plus 6t, in the brackets I should see t plus 3, and t plus 3 is indeed what I've got in y. So actually, if I find an expression of t plus 3 something with x, I can sub it into y, and therefore find my Cartesian equation. So that's exactly what I'm going to do. So I'm going to say x equals t plus 3 whole squared minus 3 squared minus 16, and that will give me x equals t plus 3 whole squared minus 25. So therefore t plus 3 is going to be equal to the square root of x plus 25. Now we can sub this into the y equation to give us y equals 6 ln of square root of x plus 25. Now the key thing here is that the answer that they've given us, we can clearly see there's no square root. So we actually need to get rid of the square root, and here we can use the log rules again. So I can say that's going to be x plus 25 to the power of a half, and therefore y is equal to 3 ln of x plus 25. And that's my answer. Okay, next question says, curve now cuts the y-axis at point P, so that tells me right away that my x is 0. Show that the equation of the tangent C at P can be written in this form. Okay, so if we're talking about tangents, again, we are talking about the first derivative, right? And since we now know our Cartesian equation y equals to x something, find the first derivative. We know the point at which we're going to find the gradient, which is x equals 0. We also can find what's the normal y coordinate by subbing in x equals 0 into our normal equation, our normal function. And we can use that into y equals mx plus c, and therefore find the rest of the equation. So that's exactly what I'm going to do. So to start off, I'm going to just do a bit of housekeeping, and I'm going to say x equals 0. What does y need to be? Y needs to be ln of 0, 3 ln of 0 plus 25. So that's 3 ln of 25. Okay, so that's my coordinate of that's my coordinate pair x and y. Next, let's find dy dx. So dy dx is going to be equal to, since it's a natural log, it's simply just 1 over that. So 3 over x plus 25. And then dy dx at x equals 0, again, is 3 over 25. And that's my gradient of the tangent, so m tangent. So therefore, I get is y equals 3 over 25x plus c. So at this point, we can sub in the coordinate that we found earlier. So we can say at x equals 0, y is going to be equal to 3 ln 25. So 3 ln 25 is equal to c. Now, I saw from the corner of my eye that it was ln of 5. So we need to turn this 25 into 5. And the best way we could do this is by saying 25 is 5 squared. And we can use the power rule to bring the power down. So 3 ln of 5 squared equals c. So therefore, c is equal to 6 ln of 5. So finally, y is equal to 3 over 25x plus 6 ln of 5. They want all the x and y's on one side, so we'll just need to simplify this a bit more. So if I times both sides by 25 each and bring the x on the left hand side, again minus 3x plus 25y and 150 ln 5, and that is my final answer. Let's keep going. Okay, so we're given some fraction. They want us to use partial fraction in terms of k. So it looks like this is just linear factors, your very standard partial fractions. And do let me know if you'd like a video on partial fraction. I'm thinking of doing it at some point, going over all the different cases that you need to know for partial fractions. But in this case, it's a linear factor. We can therefore say it's going to be a over one of the factors plus b over one of the factors, where a and b are constants. Okay, so we can say 3kx minus 18 over x plus 4, x minus 2 is equal to a over x plus 4 plus b over x minus 2. So now if I multiply by my denominator, so this entire thing that you see, if I just multiply everything by that, I get is 3kx minus 18 is equal to a times x minus 2 plus b times x plus 4. So now I'm going to use something like the inspection method again to compare my coefficients of x's and also the constants. So what I'm going to get is let's simplify this a bit more to get, in terms of x's, I'm going to get is a plus b. And in terms of constants, I'm going to get is 4b minus 2a. That x looks not very great. So if I compare the x's now, I get 3k is equal to a plus b. And if you look at the constants, again, minus 18 equals 4b minus 2a. So what I could do is divide everything by 2 here. So again, minus 9 equals 2b minus a. And finally, we can say that a is going to be equal to 2b plus 9. And we can sub this. Let's say this was equation 1. Then this is equation 2. So 2 and 1, if I substitute that, I get is 3k equals 2b plus 9 plus b. So I can simplify that also. 3k equals 3b plus 9. Divide everything by 3 here to give me k minus 3 equals b. So I'll just simplify that all. And similarly, a would be equal to 2 times. So that's 2k minus 6 plus 9 to give me 2k plus 3. So I would just practically simplify that all. So I've taken all of b, put it into a, and just gone with it in one line. Hope I didn't go too fast. Okay, next question says, find the exact value for k for which we have this integral, and this integral is equal to 21. So this integral is integrating the partial fraction, so that's why they ask us to do the partial fractions in the beginning. So part B, we're integrating between minus 3 and 1 of, so we've now simplified our expression. So that's 2k plus 3, not minus, over x plus 4 plus b, which is k minus 3, over x plus 2 minus 2. Yeah, I thought so. Dx equals 21. Okay, so let's actually go ahead and integrate these. So hopefully you can see that this is going to be a natural log, because we have the entire bracket is to the power of 1, so we can say this is just going to be a natural log integral. So I'm going to get is 2k plus 3 and ln of x plus 4. And remember, when you integrate using the natural log, make sure you use your moduli operator, okay? Because it only can be positive, it can't be negative. And then plus k minus 3, x minus 2, between minus 3 and 1 equals 21. So let's sub in 1. What do we get? So brackets 2k plus 3, it's going to be ln of 5 plus k minus 3 ln of 1. That's good, because ln of 1 is 0, so we can actually say this is going to go to 0. Lovely. Then minus 3, 2k plus 3, that's going to be ln of 1 again. That's my lucky day, maybe. Plus k minus 3 ln of, so this is where it's very important that you use your modular operator, because I'm going to sub in minus 3 in there, and because it's minus 2, I'll get minus 5. Now you might be asking, well, how does it work then if it's minus 5? But because it's a moduli, we can actually take the positive bit. So we can say that that's going to be ln of 5. That's the whole point of having the moduli. And that's equal to 21. So let's simplify this all. So I can say 2k plus 3 ln 5 plus k minus 3 ln 5 is to 21. Oh, that shouldn't be plus, should be minus there. Cool. So let's expand it all, simplify it. So plus 3 ln of 5 minus k of ln of 5 plus 3 ln of 5, and that's equal to 21. So I get is k ln of 5 plus 6 ln of 5, and that's equal to 21. And finally k is going to be equal to 21 minus 6 ln 5 all over ln 5. Okay, exact value right there. Right, let's carry on. So we're up to question 11 now. So we have a tank of some sorts. We have its volume, which is 20 by 10 by 5, which is 1,000. Then we know that at t minutes, water starts flowing in at h. The volume of h would be equal to 200 h. That's v. That's this v right here. And we know that v is inversely proportional to square root of h, and we want to show some kind of relationship. So with these kind of questions, usually the trick is that it will be some kind of chain rule question where you have to find multiple, maybe 2 or more relationships and chain them together to find the expression that you're looking for. So in this case, we're looking for dh dt. So that's question 1. So dh dt. What we're looking for is that something with dh in the numerator, right? We want something that has dh in the numerator over something, and I need dt in the numerator again for something. And looking at what we know so far, given that v is inversely proportional to the square root of h, and the fact that we also know what v is in terms of h, we can therefore, I'm inclined to say that it will be something to do with dv. Okay, makes sense. Now dv dt, the rate itself, because they tell us that the rate of change of v is inversely proportional to the square root of h, so dv dt actually is going to be equal to some k constant that we don't know of. It's a constant proportionality over square root of h. Whereas v is equal to 200 h, as we established, that's this volume right here. So that came from finding the cross-sectional area and just times it by the height. So that's 200h. So we can find what dVdh is going to be. That's going to be 200, but we need dH/dV, so therefore we can say dH/dV is going to be 1 over 200. So now that we have everything we need, we can say that dH/dt ultimately is going to be equal to k over square root of h times by 1 over 200. And looking at the expression they want something that is a lambda over square root of h. So this lambda could be everything else other than square root of h. So in this case, that lambda can be k over 200 times 1 over square root of h. And I can say this right here is going to be lambda. So I get lambda over square root of h. And that's exactly what they wanted, right? So QED for that. Cool. So question B. So we're told some values now. So initially, so that's t equals 0. The water is 1.44. 8 minutes after, now the water height is 3.24. So for us to actually, yeah, so there you go. So the next question is giving us a hint that we should be integrating. Now, why did I know it was going to be integration before even reading out the rest of the question? Because they're telling us the actual height. Now, if you look at our relationship at the moment, it's the change of height, right? It's not the height. So if they start talking about the height, what they're implying is that you need to be able to find the actual function, which you'll get to by integrating the derivative. So we're trying to integrate this dH/dt equals to lambda over square root of h. Fine. So we can just cross multiply and simplify it that way. So square root of h, I'm going to write this as h to the power of half dh equals lambda dt. Let's integrate. And I get add 1 to the power, divide by the new power. That should give us 2/3. h of 3 over 2 equals lambda t plus c. Now for us, we need to find this plus c. So we know that at t equals 0, what was the height? 1.44. So 1.44. So if I just put this in my calculator, so c is going to be equal to 2/3 of 1.44, 3 over 2, square root of it, which is going to be 1.2. 1.2 cubed is what? Whatever that is, times by 2/3. 1.152. So 1.152. That's my plus c. Therefore, I got the relationship of 3 over 2 equals lambda t plus 1.152. Now we need to find this lambda next. So this is the second set of values they told us. 8 minutes in is 3.24. So at 8, t equals 8, h is equal to 3.24, I want to say. Have I forgotten already? Sorry. No, I got it right. So lambda t is going to be, lambda is going to be equal to 2 over 3, 3.24, 3 over 2 minus 1.152 all over 8. So that's just me rearranging everything so I can put everything in my calculator neatly. All right, that's going to be a pain, isn't it? So 2/3, so 2 over 3, then multiply that with 3.24, and that is to the power of 1.5, minus, so I should actually use another set of brackets actually, just to be on the safe side. Shouldn't be an issue, but in an exam you don't want to lose a trivial mark just because you didn't use another set of brackets. Over 8. Oh, what happened there? Yeah, there you go. So my answer is 0.342. Then finally I get 2/3 h 3 over 2, 0.342 t plus 1.152. And they want it, I think, in just, yeah, they just want h on its own. So if they want h on its own, I just need to basically divide everything by 2/3. So therefore h 3 over 2 equals, if I divide this number by 3 over, actually divide this by, I'm dividing, right? So 2 over 3, actually, to get an answer of 0.513t plus 1.152 divided by 2 divided by 3. 1.728. 728, and that's my answer. Cool. Part C. What does it want now? So find the time taken when the water starts flowing in. So till it's completely full. So if it's completely full, our H is now going to be equal to 5. Okay, so that's what they're trying to infer. So I need to find what T is when H is equal to 5. So 5, 3 over 2 equals 0.513 T plus 1.128. So therefore T is going to be equal to 5, 3 over 2 minus 1.728 all over 0.513 to give us an answer of 5 to the power of 1.5 minus 1.728, sorry, 728 over 0.513. Okay, 18.4. How many decimal places? They don't really say, and it's in minutes, right? Trying to scan where minutes is mentioned. Surely, yeah, there you go. T minutes. I don't know how I missed that, but yeah, 18.4 minutes. I'm happy to leave it at that. Minutes to 3SF. Happy to move on. Okay, so two graphs, two modulus functions. Company A, company B. Music streaming companies. Okay, cool. Looks like they've got an inversely proportional relationship, it seems. Okay, 5-year period. Cool. Find the initial difference between the subscribers in company A and company B. So effectively at time t equals 0, that's what we're looking for. So if we start when t equals 0 in both equations, get the numbers, and it's in thousands, right? Yeah, there you go, that would make sense. So my two equations are NA. I'm just going to write the equations because I think I don't want to keep scrolling up and down. So that's going to be 8 minus 2t minus 6. Alright, cool. So part A, so we're looking at t equals 0. NA is going to be equal to, well, minus 3 plus 4. So that's going to give me 7. And B is going to give me 8 minus 6 minus. So that's going to give me 2. So we want the difference, right? Yeah, initial difference. So therefore, diff is going to be equal to 5,000 because it's in terms of thousands, right? So 7 minus 2 times by 1,000. That's it. Cool. Right. So when T equals capital T, company A reduces subscription prices and the subscribers increase. So just the value for T. Right. So looking at T, so it seems coincidence that they decrease the prices. So this is the one that's A. So this is the one that's A. So it only really makes sense for them to decrease the price at this specific time because that's capital T. It only makes sense to be that time because that's when it dips the lowest and then it goes up, presumably because they've decreased the prices. Now, looking at the equation for NA, I hope it makes sense to be 3 because we want the lowest possible subscriber count, right? And the only time we can get the lowest possible subscriber count if T is indeed equal to 0. And that would give me, what am I looking for? So suggest a value of, sorry, T would be equal to 3. When I said 0, I meant the entire thing has to be equal to 0. So I get 4, okay? So, and that kind of coincides with the graph as well. So you're looking for a number that is somewhere in the middle of 0 and 5. So it makes sense to be 3 in this case. So I'm going to say T equals 3 years. Give a reason. That's the lowest subscriber count. So, subs count. Just gonna leave it at that. Let's see. Find the range of values for T for which NA is greater than NB using set notation. So effectively what they're asking you to do here is to solve the modulus equations. Now, key thing to remember here, when you solve modular equation or modulus equations, you have to consider both the positive case and the negative case. That's why it's a 5 marker, right? It only makes sense. So let's consider the both cases. So when both of them are positive, so the positive case, we have t minus 3 plus 4 equals 8 minus 2t plus 6. So let's solve these. I get 3t. I'll get 1 here and 14 there. So that will be 15. No. I'll get minus 3 plus 4 to give me 1 here. Plus 1. Plus 1 here. Actually, I'll just write it down. Plus 1. 8 plus 6. That's going to give me 14 minus 2. Oh, there's no minus 2t now. And therefore 3t equals 13 and t equals 13 over 3. And then the negative case, we have t, so I'm going to stick in a negative in front of the basically the modulus. That's where I'm going to stick the negative in. Minus 3 plus 4 equals 8 minus 2t. So it was plus 2t, right? Yeah, plus 2t and minus 6. But since there was a negative in there, so this will become positive now. Minus 6. So again, minus t plus 3 plus 4 equals 8 plus 2t minus 6. So I have 3t again plus 7. Actually, 3t plus... Let's go step by step because I think I'm messing up the arithmetic somehow. Minus t plus 7. 2 plus 2t. So now let's gather all the t's together. So I get 5 over 5 equals 3t, so t equals 5 over 3. Now what do we need? So we need to find the range of values for which NA is greater than NB. So looking at our graph, we can see that NA is greater. So the two values that we found, those are the two intersections. So this is a 5 over 3 and this is 13 over 3. So effectively we're looking for answers where, so we're looking for t such that t, so set notation, t such that t is less than 5 over 3 and t such that t is greater than 13 over 3. Cool. Part D. State a limitation of the model used for company B. So company B equation that we can see. So let's think about, obviously we stop at the 5-year period, for which we still do get a positive subscriber count. However, let's think long term, beyond 5 years. Let's say 10 years. When we start in t equals 10 here, we get 14, and then we'll have 8 minus 14. Clearly, we can't have a negative subscriber count because that physically is not possible. So that's the biggest limitation of this model, is that the sub count becomes negative as t approaches infinity. I mean, it's infinity, we say, but you know, just mathematically talking about this, but however, even like at t equals 10, as you can see, it will become negative, which is impossible, which is, I mean, physically impossible. That's what I should say. All right, let's move on. I think that was all. So now we have question 13, so let's carry on. Right, so it's a binomial expansion and we've been given the expression. So when it comes to negative powers, what we know we can expand is something that is 1 plus x to the power of n. And this doesn't necessarily need to be just x. It could be x divided by some other number a. It could be multiplied with some number b. As long as it's 1 plus, I think the most key important part here is that 1 plus something. All right, so our plan is, can we put this expression into 1 plus x something? And we can do so by just pulling the 3 out. Now when we do actually pull the 3 out, we need to make sure we respect the power. So the power actually does come with it. So 1 plus x over 3 minus 2. Now we know that this expression, this expansion looks something like nx plus n minus 1 over 2 factorial x squared. And yes, that's the only first 3 terms we need anyway. So that's actually quite good. So now let's expand everything out. So I get 1 plus minus 2 times x over 3 plus minus 2 minus 3 over 2, because 2 factorial is just 2, times with x over 3 whole squared. And they want it in the simplest form, so I would actually have to do a bit of simplification here. So we get is 6 divided by 2, then divided by 9, right? Because of the x squared over 9, x squared over 3, so that would give, so that we need to keep in mind, should give us plus 1/3 x squared. And then since they want simplest form, we have to expand everything. 1/9 minus, we get is 2 over 27 x plus 1 over 27 x squared, and that's our final answer. Right, part B. So use your answer to part A to estimate this answer. And I hope you can recognize here right away that it's simply 6x multiplied with the expression that we had from part 1 of the problem. So what we can do therefore is, since it's an algebraic expression, we can multiply the 6x out to get one big expression that we can integrate polynomially. So part B. So it's 0.2 and 0.4, I believe. 6x multiplied with 3 plus x to the power of minus 2 dx. So 0.2, 0.4, 6x multiplied with 1/9 minus 2 over 27 plus 1 over 20, don't forget the x squared dx. So now let's multiply things out. 0.2, 0.4. So we'll get is 2/3 x minus, so if it's 6, we will get is I believe 4 over 9, but I'm just gonna double check this because I don't really want to make any mistakes. So 6 times 2 over 27, yeah, 4 over 9. Okay, minus 4 over 9 x squared, and then 6 over 27, we're looking at 2 over 9, so plus 2 over 9 x cubed dx. And at this point we'll just integrate, so add 1 to the power, divide by the new power, so we get is 1/3 x squared here, plus or minus, so we'll divide by 3. So if we divide by 3, we're looking at 4 over 27 x cubed, plus now we're going to divide by 4, so that's going to give me 36. So that's going to give me 1 over 18 x to the power of 4 if I simplify this. So at this point what I'll do is I'm going to just go away and compute the integral, because it's going to take a while to put into my calculator, and once I've got it I'll join you back. Right, so after putting it into my calculator I got an answer of 0.03304 to 4 significant figures. So yes, they wanted 4 significant figures, so we left it at that. Now part C, they want us to actually find the exact value. Okay, so we actually have to integrate this thing exactly, and they want it again in exact form, and we can see a ln in there. All right, cool. So I've got a few ideas on how we can integrate this thing. So that's 6x over 3 plus x squared dx. My first sort of inclination is to do a u sub integration. So we can substitute, let's say, let u equals 3 plus x, so then x is equal to u minus 3. Then if we did dx du, we just get 1, so that means dx is equal to du. We can also do the change of our limits. So since u is equal to 3 plus x, the new limits will just become, so the limits will simply become u1 is going to be equal to 3.4 and u2 is going to be equal to 3.2. Alright, so now let's rewrite everything So I get is 3.2, 3.4, 6 times x, which is u minus 3, all over u squared, times with, well, that's just du, because dx is equal to du. Alright, so next what I could do is I can split the fractions into individual fractions. I think that's how I'll get the ln that was in the answer. So they've given us how the answer would look like, and there's a natural log. So we need something that is of a power 1 in the denominator. And to have that, I've got to divide the fractions into individual bits. So the common fraction. So 3.2, 3.4. So 6u over u squared minus 18 over u squared du. So now I can simplify this a bit. 3.2, 3.4 to give us 6 over u minus 18 over 18, I guess u to the power minus 2 du. So now let's integrate this. So I get 6 ln of u minus, so now add 1 to the power, divide by the new power. So adding 1 to minus 2, that will give me minus 1. When I divide by the new power, I'll get a positive. So I'll get 18u minus 1, 3.2 and 3.4. So this is an exact, yeah, it's an exact answer question, right? Yeah, it's an exact answer. Okay, so right, let's start by subbing in some numbers, I guess, and we'll see how that goes for us. So let's sub in the first limit. Sorry, apologies. So if we sub in 3.4, I get is 6 ln of 3.4 plus 18. I'll just compute that numerically because I can just use my calculator for that. So what am I trying to do? I'm trying to do 18 times with, I guess I'll just use a fraction, 1 over 3.4. So that's 90 of, actually I'll just use fractions, that's fine. 90 over 17 minus, I'll have 6 ln u, which is 3.2, plus, so instead of that, now we're going to have 3.2, so that's 45 over 8. So now let's take these away. So since we got a ln, and let's see if there was a 6 in there. Okay, so it's definitely a times ln b. So the 6 can definitely be there. So I'll have 6 ln of 3.4. And since there's logs, I can just use the log rule here and do 3.4 divided by 3.2. And because it's 6 as well, so I can take the 6 as a common factor out. And what's 90 over 17? Take away 45 over 8. Okay, so minus 45 over 136. And I can simplify this furthermore. I did 3.2 to give me 17 over 16. So 6 ln of 17 over 16 minus 45 over 136. And that's my final answer. Yeah, so let's carry on. Okay, so next we got a trig question. Right, so a few identities that come to my mind already. 1 plus 10 squared, that is sec squared theta. If you don't know where that comes from, I'll just quickly show you. So it's sine squared theta plus cos squared theta is equal to 1. We know that. Remember that sec squared theta is same as 1 over cos squared theta. So if we divide everything by cos here, I get sine squared over cos squared plus 1 equals 1 over cos squared theta. And clearly that's just 10 squared plus 1 equals 1 over cos squared theta. So that's just sort of where it comes from if you didn't know. So I'm just going to wipe that. Not really important to this question. So we identify that that is indeed 1 over cos squared. Cool. And looking at this, we need to have something that is 2 sine. So this identity is 2 sine theta cos theta. So we need to make something that looks like that. We have cos square in there, so I presume that comes with the sine squared. So again, it's the same formula that I just went over. Sine squared is equal to 1 minus cos squared. Sorry. I think my pen just stopped working. No, sorry. Just selected something. Cos squared theta. Okay, so I guess, yeah, let's crack on with it. See where we go with this question, right? So part A, 2 tan theta. I guess what I'll do is I'll just write the question down before I start messing with it. The only issue with writing down the question is sometimes also like I'll make mistakes copying the question down and wonder why I got wrong. So 2 tan theta, what I could do is I can say is 2 times sine theta cos theta, and I have an idea why I'm doing this, because I'll have a sec squared on the other side, and then I have 8 cos theta, and if I use this identity from here, I can say that it's going to be plus 23 minus 23 cos squared theta, 8 sine 2 theta. I'm going to keep that as 2 sine theta for now, and this is going to be 1 over cos squared theta, because that's sec squared, and we said that sec squared is equal to 1 over cos squared. So I'm going to take 2 steps at a time. Next, I'm thinking I'll just times by this cos squared theta, because I don't like it, it can go. So when I times both sides by it, this cos will cancel out with one of the coses, and the other cos will give us 2 sine theta cos theta, 8 cos theta plus 23 minus 23 cos squared theta, and that is equal to 8 sine 2 theta. And hopefully you can see that that's just sine 2 theta. So sine 2 theta, 8 cos theta plus 23 minus 23 cos squared theta, and I can bring this minus 8 sine 2 theta around, because now what I could do is I can take sine 2 theta as a common factor out. So if I take a sine 2 theta, yeah, so just like the question, sine 2 theta as a common factor, I get is 8 cos theta plus 23 minus 23 cos squared theta minus 8 equals 0. And let's simplify that all. So for us to get sine 2 theta minus 23, what order do they want it? Yeah, so minus 23 cos squared theta plus 8 cos theta, and 23 minus 8, that should be plus 15. That's equal to 0, and that's the format they want it. So I'm gonna say Q80. Alright, so next they want you to actually solve this question. Solve this equation that we have, this expression between 360 and 540. That is a very odd selection of limits, if I say so myself. But no problem, we'll solve it. So part B. So looking at our situation right now, we have 2 brackets effectively. We have sine 2 theta and some other expression for cos. And when we have 2 expressions, we can say that, and we have 2 expressions that multiply and they give you 0, we can exploit or manipulate it by saying that then one must be 0 or the other one must be 0. Okay, so we can say that sine 2 theta must be equal to 0. Now, because it's a double angle, we need to find all the angles, what would be like double the range of the single angle. So if my range is between 360 and 540, so actually what we should be finding is all the angles up until 1080, so which is the double of 540. And then we pick and choose basically the ones, then we'll divide everything by 2 for us to end up with the angles that fall into our range that we have, and those are the ones we'll go with. So sine inverse of 0, I hope you know, is indeed just 0, because sine just starts from 0 and it does this shape, right? So 2 theta is going to be equal to 0. The next one is at 180, 360. So you'll just keep adding 180 every time. So rather than having to do this multiple different times, I'm going to say 0 plus answer, 180, then plus answer again, 360 plus answer, plus answer again. Am I bugging out? I think I'm bugging out. We said 180 plus I guess I'll just multiply it, man. Honestly, it's the same thing. Okay, 540. Now times this plus this by the answer. Oh, right, okay. We have 180 times by 5. 900. So we have 1, 2, 3, 4. And I've skipped 4 here. So that's 180 times by 4. 180 times by 4, just 720. So I'm just gonna make a little space for 720 there. 720, and I'm not gonna bother finding the 6 because that's gonna be beyond the 180 that we have anyway. So I'm just gonna leave it at 8. So that would be exactly 180. And is that in our range? Actually, it is. So you know what? Fair enough. I didn't need to figure that one out. Okay, cool. So that's 2 theta. So the theta is going to be 0, 90, 180, 540 divided by 2. We're looking at 270, 360, 450. I think that's not one of the solutions. Yeah, it can't be one of the solutions. So actually, I'm just going to cross that one out. And 1080, that's going to give me exactly 540. So those are all my solutions for the sine 2 theta. So now let's fry the other fish, which is going to be minus 23 cos squared theta plus 8 cos theta plus 15 is equal to 0. So I can come to my quadratic solver and I can just give the quadratic solver the numbers. So I have minus 23, I have 8, and I have 15. So I have cos theta is equal to 1, or something that looks a bit more funkier. So cos theta is equal to minus 15 over 23. Okay, so cos inverse of 1, right? So cos inverse of 1, and we are in radians as well. So let's just come back to degrees. So cos inverse of 1 would be 0 because I'll just draw the graph. So that starts at 1. So the first solution is 0. The next solution that we're looking for is going to be so if that is, we're looking for 1, so the next solution is going to be 360, as you can see. So that's 360, and then the one after that is also going to be 360, so that's 720. The one after that was 720 plus 360. Okay, exactly 1080. Okay, cool. So 1080. Now remember that this is the single angle, so to be honest, we don't even need to bother with these two, okay, because that's beyond our 540 limit, right? Yeah, that's beyond our 540. And I should also cross out the 0 because 0 is not needed, because the range we're looking for is between 360. So from there, we actually only really needed 2 solutions. Those are the only 2 solutions for sine 2 theta. And here, again, we cross this one out. So the only solution we have is 360. So now let's deal with this cos. So cos inverse. Now, as you can see that this is a negative answer. So, you know, when I put in the negative, it should only give me the positive angle, which is 130.7 degrees. Now, I'll try to figure this out using the cast diagram. You can equally just use a graphical method, but it's the same, sorry. 130. So that's somewhere around here, 130. And the next solution, because the way cast diagram works, we have a negative answer, so, or an obtuse answer. Therefore, we're also looking for other quadrants where cos is negative. And in this case, it has to be 10 because here everything is positive and here cos is positive. How do we find this angle? Well, it would be very beneficial actually if we just did a little sketch here. So this is how the cos graph looks like. We are looking at a value that is negative, say, let's say somewhere down there. That's our 2 solutions, right? We found one of the solutions, and remember that this right here is 180. So this is the 130 that we got. We need to find what this one is. Now, luckily for us, we can see that it'll be the same distance from 180, right? It'll be basically the same distance. So what we can therefore do is, if we find what is this bit, this difference that we have, right, this difference that we want, then we can basically figure it out from 180. And in this case, what we'll do is, if we were to put into our calculator the positive version of the answer, that's exactly what that much is. This much is 49 degrees, 49.3 degrees. Okay, so looking at our diagram, all I have to do is just add that onto 180. So 180 plus this 49 thing, 49.3, and I should get to my answer. So if I did 180 plus my answer, 229, it's good to me, 229.3 degrees. And those are my two solutions between 0 and 360, as you can see from the graph. Now, remember that we're looking for solutions between 360 and 540. So we need to find other solutions for this. Now, luckily for us, that cosine is a periodic function. Therefore, it will repeat itself every 360 degrees. So all we have to do is just add on 360 to our existing solutions, and hopefully it will take us to the next solutions. So we have this plus 360. So we have one of the solutions. If I added anything more, actually this one isn't even in the solution because we're stopping at 540, right? Yeah, we're stopping at 540, so that's not even in our solution. So the only one that we'll care about is 130.7 plus 360 will be about also digits, but doesn't really matter. So actually we don't even need this one. So the one we actually need is the 490.7 degrees. So finally, all the answers that we got after crossing everything out. So for the first one, so therefore we have the first one we have is 360, 540. So there's two duplicate 360s, so I'm going to keep only one of them. The next one we have is 490.7. And the final one that we have is 540. Those are my final solutions after crossing out the monster line. Right, so on to question 15. And so this is the last paper on the question. Last question on the paper too, as you can tell the time. So we have a student that's trying to prove that sine x minus cos x is greater than 1 by contradiction, and x is not to 10. I guess that's a very important bit of information. So they started the proof by squaring both sides. After completing the proof, so my idea is let's just split the brackets, try to simplify things, then hopefully we'll stumble across something that, you know, a logic that we can use to prove that the answer will be greater than 0, and by therefore we'll prove a contradiction that the original statement was indeed correct. So let's expand this out. I guess sine squared x minus 2 sine x cos x minus plus cos squared x greater than 1. So I can actually bundle the sine and the cos together. So that gives me 1 minus 2 sine squared sine x cos x. And the reason it's 1 because sine squared x plus cos squared x gives you 1. And I can get rid of the 1s on both sides, take away 1 from both sides, so I get minus 2 sine x cos x less than 0. So here, the most important part of the question, which was, it's an obtuse angle. And between obtuse and obtuse being greater than 90, if we were to sketch the graphs, so this is 90, and we have is, right, something like that. So we can clearly see that between 90 and 180, sine is actually positive, whereas cos is actually negative. Now that is very helpful because what we have is a negative, which is coming from the negative sign, multiplied with something that is positive, multiplied with something that is negative, and that has to be greater than 0, correct? Because negative will give you positive, and then times with the positive will give you positive. So therefore we proved by contradiction that the original statement was indeed this statement is wrong, but the original statement was indeed correct. So we just write one line saying proved by contradiction. Alright, that's it for this paper. I hope you enjoyed the video. I hope you got to learn something from the video. If you did, please do like the video. Subscribe to the channel. We're starting out, brand new channel. So any sort of engagement can really take us far. If you have any questions,